Before I proceed with the terminologies and the introduction on the properties related with our analysis later, there will be two approaches to find the properties, which is the first one by using the equation or formulas, and the second one will be finding all those properties using a psychrometric chart. During this introductory of the properties related with air conditioning, I'm going to show you the equation or formulas in order for us to find that particular property. We're going to start with specific and relative humidity of air. Generally, they represent the quantity of the water vapor present in the unit mass of dry air. The first property is specific humidity or absolute humidity or humidity ratio. But most of the time, in our discussion, we are going to refer it as specific humidity. The specific humidity is the ratio of mass of water vapor present in a unit of mass of dry air. Again, the ratio of water vapor mass over mass of the dry air. The symbol for specific humidity is omega. Although it is a mass ratio, but since it is a ratio of two different substances, which is the first one is the water vapor and the second one is the dry air, therefore you're going to have in the unit of kilogram of water vapor over kilogram of dry air. Since we know that PV equal to mRT, and if we rearrange so that we can have the mass as the head of the equation, we're going to get mass equal to PV divided with RT. And if we substitute this to the general form of the specific humidity, we're going to get in the form of this. Please note that whatever property with the subscript V is representing the property for the water vapor, and for the properties with subscript A is going to represent the property for the dry air. Let's say we take atmospheric air, which we know that contains of water vapor and dry air, in the volume of 1 meter times 1 meter times 1 meter. And if let's say this atmospheric air having a temperature equal to A degrees Celsius, we can say that the dry air and the water vapor are sharing the same volume and the same temperature. We can now simplify our equation to these terms. Now, from the property tables at table A2, the value for specific gas constant R for the dry air is given by 0.287 kilojoule over kilogram Kelvin, and the value for the specific gas constant R for the water vapor is given by the steam is equal to 0.4615 kilojoule over kilogram Kelvin. Now, from this equation, if we substitute the values for the specific gas constant for the air and also the specific gas constant for the water vapor, we are going to get this value, 0.622. Thus, we will have omega equal to 0.622 PV over PA. And we know that from previous, pressure is equal to partial pressure of the dry air plus partial pressure for the water vapor. We can rearrange so that PA equal to P minus PV. And if we substitute PA equal to P minus PV to the omega relation, we're going to get omega equal to 0.622 PV divided with P minus PV. You might want to familiarize yourself with this relation for the specific humidity. For relative humidity, the symbol assigned is V and is defined by the ratio of the amount of moisture the air holds to the maximum amount of moisture that the air can hold at the same temperature. The terms mV is representing the mass of the water vapor that is being held by the atmospheric air at the present time. Meanwhile, the terms mg is representing the maximum amount of mass that the atmospheric air can hold. The subscript G is actually representing the terms saturated vapor. And again, from the ideal gas equation of state, we can have this relation. We know that they're having the same volume, the same temperature, and they are both water vapor. What's left with us now is the pressure terms, which is PV over PG. And we know that the pressure for the saturated vapor is given by the saturation pressure at a given temperature. If we combining the equation for relative humidity with the specific humidity as discussed previously, we can get these two equations. Which showing the relation between specific humidity and also relative humidity. For your information, the relative humidity changes with temperature, while the specific humidity will remain constant. As the temperature increases, the relative humidity decreases. And if the air is saturated with moisture, we are going to term it as saturated air.